So welcome to my talk about RDDs, Spark, Shell, and WebUI. I hope many of you have seen these tools already, but I hope share some good stories I learned after spending over 100 days, consecutive days with Apache Spark and looking at the source code, taking notes, and trying to master Apache Spark, looking at the source code rather than using it and be a data scientist or machine learning expert or whatever. I needed to master programming language Scala, so I picked Apache Kafka first. But then they moved from SBT to Maven or to Gradle as a build tool, so I hated them and said, okay, never. So I switched Apache Kafka to Apache Spark, not because Spark was a growing wave, the hype was not there yet, or at least I didn't see it. But I needed a project that showed me the use of Scala, the programming language I was into. So I started looking at the source code, and that's exactly half an hour about what I learned looking at the source code of Apache Spark. So my name is Jacek Laskowski. I'm an independent consultant working exclusively now with Spark and Scala. I call myself or consider myself as a software developer, trainee, instructor, mentor. I'm leading teams. I'm developing software. Many-hat person. I love coding. Whenever I can, I hack. Well, the code, the quality of the code is not that good, but I'm working on it. Okay, and as I said, I'm into Spark and Scala these days, with some other cool technologies. And while doing it, while pursuing my understanding of Apache Spark, I'm leading two meetups in Warsaw. I'm originally, I live in Warsaw in Poland, Europe, for those who can't, zoom in. It's Europe, okay. So I'm from the other continent. And, so I'm leading two meetups, Scala and Spark meetups, just to, get into the details faster. I'm also a Java champion, but after 10 years working with Java, I decided to switch to functional programming languages. I started with Clojure, then I moved to Scala because nobody cared about Clojure at the time. So I said, okay, if Clojure, didn't get much attention, so I switched to Scala and never looked back. So that's my story, pretty much. So, as I said, I'm taking notes about Apache Spark, and every day, Sundays, Saturdays, I'm looking at the changes, the source code, and trying to grasp the concept of Apache Spark. I'm not machine learning expert. I haven't finished any studies around, machine learning. I just finished computer science with, enough scores to pass the exam and, finish master science degree, I'm done with university. But then, I just noticed that, there is this Spark. So it sparked my interest. So I'm into, Spark now. And so after 172 days, I collected my thoughts, and I called them, unfortunately, I called them Mastering Apache Spark. There is a book from Pact called same. And that's pretty much it. That's what I got so far. Okay, so what is Spark context? I'm pretty sure that everybody knows the Spark context, because this is the way to ecosystem of Apache Spark. Apache Spark is pretty much Spark context plus additional services that are attached to Spark context. So when you start your application, your Scala, Python, Java application, you have to start Spark context, obviously, right? So when you start Spark context, you effectively connect to local or Spark cluster. And this is a living space for RDDs. So as you see, RDD, single RDD belongs to one and only one Spark context. That's it, no sharing. You cannot share RDDs between Spark context. Well, you may find ways to share RDDs across Spark context, but it's not by default. By default, RDDs are designed for one Spark context. Spark context is a living space for RDDs. So and so if you need to share data between, between context, you need to persist it to, to a NoSQL database, Cassandra or Postgres, whatever, or, other, file system, HDFS, whatever. But, okay, and Spark Context internally tracks the number of RDDs created. So when you print or stringify RDD, you will see the identifier of RDD, which is the number of RDDs created so far. Yeah, so it might be useful, might not. Okay, so use to string to know it, and this is the sixth instance of RDD created so far. Not very many, but you will see more than 6 probably in your applications, in your Spark applications. So visually, I'm not good at, graphic. I just started using, tools and to convey the idea of what I learned or what Spark offers. So this is the living environment of Spark context. You can do whatever you want with RDD inside a single Spark context. That's it. Questions? It's obvious stuff, huh? Okay. Moving on. So RDD. Resilient distributed data set, not to be confused with the latest and greatest data set in Spark SQL. Not sure why they picked this name, but data set is RDD for the moment. Excuse me, Mike. Okay, so creating RDD. There are many ways to create RDDs. You can parallelize, not yourself, but the data you want to play with. And it's nice. I don't know the story why they picked parallelize. Probably, the thought is they needed to parallelize the data they need to process using, multiple machines in the cluster. So, but when I saw the name the first time, I was paralyzed. It was like, whoa, okay, is this what they aim for? Okay, so this is the parallelize, and I guess that many of you use this while working with RDDs, unless jumped on SQL, Spark SQL extension, and never seen RDDs because, well, there are some wise people who says that RDDs are assembler for Apache Spark, while Spark SQL is the way to use Spark. Okay, so parallelize. The other method is called scrange. And it's pretty much like parallelize, but parallelize is more general. Range is to create RDDs of longs or long numbers. So if you're lazy, and you should, while using Scala, yeah. So if you're lazy, use range if what you need is RDD of long numbers, because it gives you the start and step and slices. Slices is the point. Okay. Oops. Too fast. Okay, so text file. Text file is another way to create an RDD. You just fetch the data lazily until you execute an action to process the information that's inside text file. Okay, and again, name of the file and the number of partitions you need. Before, it was called slices. Now it's partition. Be careful. I'm going to explain it soon. Okay, and whole text files. To be honest, I've never used this method, but it's useful. It could be useful to fetch all the information that sits in files in a single directory. And it creates an RDD of a pace, of file names, and the contents of the file. So these are the ways to create RDDs. There are many more, many more advanced ways to create RDDs, but these are operations that are available on Spark context. Questions? Should be none. Okay. Okay, so partitions and slices. As I told you, I started my story with Spark because I needed a project that uses Scala. And when I first saw the partitions and slices, it was like, is there any difference between these two topics? And to be honest, there is none. Because slices, I'm weak at Hadoop, ecosystem. Slices is the way to call partitions, and that's how HDFS partition data. It slices the data. So when you see slices, think about partitions, because this is the way to call slices in Spark. That's my way to explain it. Please correct me if I'm wrong. So partitions, slices, are the level of parallelism. Are you paralyzed now? Shocked, surprised? Who haven't heard about level of parallelism in Apache Spark? I did, but I invite you to raise your hand if you didn't. Okay, good. So level of parallelism is a way to parallelize, streamline your processing across your cluster. And I'm going to explain it a little bit later. So creating RDD, a better way or modern way to create RDD is to use DataFrames. So DataFrames is the way, that's my perception, the way to create RDDs or to process the data, semi-structured data now in Apache Spark. Well, I started with RDDs, so it took me a while to figure out that I shouldn't have started with RDDs. But then I understood why DataFrames are better, because there is this higher abstractions atop RDDs. So all you learned so far about RDDs in Apache Spark applies equally to DataFrames. But hey, it's often that you don't have much time to tweak RDDs, because it's like coding in assembly. If you can use Scala or Java, why not? So RDDs I saw last year, and now use DataFrames, or better, data sets. Well, I don't mean using RDDs again. So it's kind of a loop. So a data frame is a higher level abstraction over RDDs and semi-structured data. So you can play with the data in different ways. So, and you need something which is called SQL context to play with data frames. Okay, so let's have a look how to create data frames out of RDDs. So this is the way to create an RDD. I use parallelize, and then, well, I'll use this. And then I use this 2DF that transforms my RDD into a data frame. Now I created a data frame out of RDD, and then if I'm not satisfied with the column name, because this is 1 now, I can use this to data frame and give the name of the columns that the data sits in. Okay, and vice versa. I can create RDD and then take RDD. I can create data frame and then take RDD out of realm of data frames and create RDD, because underneath data frames are RDDs. Okay, so you can create data frames using create data frame. Okay, good. And there are other means of creating data frames, but okay, this is just to show there are ways to create something which we will use now in execution environment. So execution environment. There are many ways to discuss execution environment for Apache Spark. You can look at task scheduler, DAG scheduler, or you can talk about clusters that Apache Spark supports. So let's talk about clusters. So let's look at parallelism or internals of Apache Spark through the lens of parallelism, through how our data is parallelized or distributed. So the number of partitions of a RDD is roughly the number of tasks. Roughly, because you can change it, or there are some optimizations that might be applied. So number of tasks. I haven't explained it yet, but to be fast, how much time do I have still? 10 minutes, okay. So partitions are just hints to size jobs. So when you execute an action, you just spawn a job, launch a job, well, run a job that will end up as a set of tasks. So It's called task sets. And task is the smallest unit of execution. You cannot chop, tasks into smaller pieces. No, task is the smallest unit. So tasks belong to task sets belong to stages, and stages belong to jobs. That's how it works, or how it is inside Apache Spark. So when you create your data abstraction, be it RDD or DataFrame, they all end up like a set of task sets that will get run on Apache Spark clusters. And jobs, stages, and tasks are displayed in WebUI, which we'll see a little bit later. So partitions and level of parallelism, you can see how many cores or how many distributed tasks you will launch using this default parallelism attribute of Spark context. So can you guess why it's 8? Because there is this number of cores I have on my laptop. So 8 is the default level of parallelism for my Spark shell in this configuration. I can tweak it, I can change it to whatever I want, but this is just a hint. So, and I'm using master local star, which I'm gonna use for a moment. So task scheduler controls tasks, and it uses this hint just to distribute the processing. So using the Apache Spark cluster, it knows how to play well and utilize all the cores that are available in a cluster. Task scheduler, and scheduler backend are pieces that are responsible for proper execution of your actions, because only actions are executed. They do something meaningful for you. But these are the low-level pieces of Apache Spark that handle the execution. So DAG Scheduler, as the name implies, manages a DAG graph of RDDs, aka, well, not this aka, but RDD lineage. And I'm gonna explain what RDD lineage is in a moment. But just to point out, scheduler backends manage task sets and talk to DAG scheduler and task scheduler and for proper execution of the actions. Okay, so this is the visual way to represent DAG scheduler, or what DAG scheduler does when it receives an action. So this is the driver. I haven't explained driver yet, and I'm not gonna do this, sorry. So there's this driver where Spark context lives, and this is the RDD that's partitioned, and action is triggered that will result in result stage. This is the stage, the kind of stage that's gonna be created after action is launched or run. And this active job is linked to this result stage, and then there are a bunch of partitions. Okay, so this is task scheduler and the interactions between different parts of Apache Spark. This is very low-level information or diagram. This is the Spark context that launches Spark or creates task scheduler and scheduler backend, and then they talk to each other to exchange information about jobs, about stages and actions. Okay, so RDD lineage is just a graph of RDDs, because RDD can depend on other RDDs. While creating your transformations, you create this lineage. And this lineage can be displayed, or let's call it graph, because it's much easier to me. So this graph is easily displayed using this toDebug string. So toDebug string is to know the lineage. And it's important because you need to avoid having too many loops or hoops. Yeah, I know that 5 is the maximum number of hoops. Yep. Okay, so they introduce something which is called shuffle barriers. So the number of barriers or shuffling how to say, says a lot about how fast your job will be processed or performed. So why is it important? Because the R in RDD, resilient distributed dataset, stands for resiliency. So when a task dies, or well, is not finished properly because a node dies that was responsible for a task, RDD keeps all the information that's needed to recover from this situation. So instead of doing all the processing again and again, it can just process one task that failed. That's it. The other tasks are fine, are waiting for the remaining tasks to be completed. That's pretty much it. Okay, and the deep, the graph can be very long. The graph can be very deep. So you need to shorten it at times because it takes time to process the information. So you persist it or cache it, to cut the number of dependencies RDD has on other RDDs. So effectively, your processing time will get shrinked, or hope so. So this is a kind of a demo on a slide. I'll have some demos on my laptop. Not sure if I have enough time. Anyway, so what does this do? So I parallelize 10-element collection. Then I map it over to create a collection of pairs, and then group by first element. Pretty much to create a collection of pairs. Yeah, that's pretty much it. So how many stages will I end up with? I can just use toDebug string and see the hops, I don't know how to call it properly. Let's call it hops. So this hop introduces a shuffle barrier. That means that all these tasks have to be finished before these tasks that belong to this group will get started. That's pretty much it. And then, hey, you won't be able to see it in WebUI yet because nothing has been triggered, nothing has been run. So all in all, you can use Spark Shell only to see the low-level details of RDD for now. So nothing happens yet. We are just preparing our processing. So Spark clusters. Spark supports 4 clusters. Well, one JVM local cluster. Let's call it a cluster. But it's just one JVM. And there's this Spark Standalone, Apache Mesos, and Hadoop Yarn. -- master command line option is to point to the cluster you are going to use. So you can have many clusters and then just point to this cluster if it's more powerful than the others using -- master command line option for your application, for Spark Submit or Spark Shell. So and this is the URL of Spark Standalone. So by default, this port is 7077, and host name is usually localhost or your local host name. And you know the local master URL, don't you? It's just local, or local N, or local star. Local means one processor, one CPU only. N means N processors, or N cores for default level of parallelism, and star means take the number of CPUs that are available on the machine. That's pretty much it. And then mandatory properties of any Spark application. So fill the gaps. So any Spark application must specify, hint, application name, aka app name, and master URL. So these are 2 mandatory properties of any Apache Spark application. So I'm supposed to have 3 minutes more. Yeah, thank you. So I'm gonna show you, Spark Shell with in local mode and using Spark Standalone. Hope some will find it useful. Okay, so this is Spark Shell. So when you start Spark Shell without specifying any additional command line options, it means that you are connecting to local, you create a local environment, degenerated cluster mode, it's called local. So if you want to see the master URL, you just type in sc.master, and you will see that your master is local star. So this is the star, this is the master, and app name is Spark Shell. And you cannot change it. Now, you can open, just to be quicker, you can open localhost 4040, and you will see the UI of your Spark application. And you can see that there is this Spark Shell name here displayed here. So this is the name of the application. And since I configure my Apache Spark with SQL, I have this SQL tab. It's not available by default, but you can have it. And same for Spark streaming. So nothing happened yet. I just started my, preparing my processing. So no jobs were triggered yet. So let's trigger some jobs. So parallelize, 0 to 10, and then collect. Just very simple, transformation processing. So I just literally parallelized 10 elements collection and collected it on my master, which is Spark Shell. So let's have a look. I just created a job, and this job shows me the number of tasks that were used to compute my processing, or that handled my processing. So 8 tasks, because this is the maximum number of cores I've got on my machine. And since I'm using local star, it means use the maximum number of available CPUs. Okay, let me switch. So I was supposed to describe a little bit of or present Spark Standalone, but I'm not gonna use slides because of not much time. So I'm gonna show you while I'm here in my shell. Okay, so this is how to start. This is the way to start Spark Standalone cluster. You just use sbin start master, and you can optionally use -h to denote the name, the host name of your master. So localhost is good. So I'm starting master for my cluster, for my standalone cluster. Now I'm gonna start my slave, which is called worker. And then I'll specify the URL of my master, which is spark : / localhost 7077. So now I'm gonna copy it, so you know how to do this, and then I'll use it to connect to my master. So as you can see, I've got no workers available. After starting one worker, I've got one available. Now, having this worker, I can connect to this Spark Standalone cluster using any application, any Spark application, which is a shell using master localhost 77. Okay, so I'm connecting to the cluster. I'm connected, or soon will be. Okay. Got it. So sc master is Spark localhost. So I'm connected. Let's have a look. Yep, I'm connected. So pretty much it, about, what you can do on your laptop with, Apache Spark and Spark Standalones and RDDs. I've got more slides than I could present, so sorry for this, but hopefully, you found it useful too. So let's start Q&A session, right? Okay, so thank you.